अब उसको बता दो कि उसे करना कहाँ है और फिर चालू उसको नहीं पता चलेगा तुम यहाँ थोड़ी खाओगे
ये अभी दिख रहा है। हाँ, ये कौन सा है? ये स्क्रीन का है। स्क्रीन का है। हाँ, मैं फोन बस आएगा। आज नहीं आया।
our event in next 4 to 5 minutes. I would like to invite everyone to come a little ahead so that the speakers can have good feeling while they are delivering something. We have registration of over 110 persons today, but due to this rain, many of them could not attend right now. So let's gather ahead. Okay. Again, a very warm welcome to everyone and a very fantastic morning again. There is a very beautiful weather outside and I hope you have all enjoyed coming over here. We have got more than 50 persons right now and I think it's very good enough for us to start this event. Okay. This is our second AI meetup which is organized by Webocal Technologies and hosted by IT Path Solutions. Last month on 20th July, on the AI Appreciation Day, 19th July, we had our first AI ML meetup. I just want to know how many of you were there in that meetup. Just raise your hands. Okay. And how many of you are invited by these people who attended last time? Okay, great. We have to increase this going forward, right? Good, good. So, few things we shared last time. This event that we organized is more, specifically it is more centralized towards computer vision, right? And today we have got another two speakers with us. One person is Mr. Karan Pal, who is from IT Path Solutions, and another person is Mr. Shuam, who is from Webocal Technologies. They have both done such presentations up to a certain level in their organizations, their companies. But again, for them, I think this is the first experience for having such session in front of a crowd like this. So we'll appreciate them and we'll give them enough space before they present their things. And before we start, I would like to highlight a couple of things about both the companies, like what kind of services they are providing. Next slide. Okay, Webocal Technologies having specializations in AI and ML, web development, mobile app development, and HubSpot development. Then if we talk about IT Path Solutions, they are having their specializations in Microsoft Technologies, enterprise content management, custom app development, mobility solutions, IoT, blockchain engineering, enterprise e-commerce, extended reality, and BI and data analytics. Good. Will not take much time right now. I will have something in between the sessions where we'll engage with everyone. We are ready to start our first session, and before that, we'll make sure the following things. Please silence your mobile phones if it is not done yet. Maintain silence while speakers are speaking. Gather your questions and ask the speakers at the end of the session. Enjoy the meetup and increase your knowledge. Make new friends and have snacks at the end of the event. Thank you very much again for coming to this event. We are really grateful to see such people coming for AI and ML meetups. Karan, we welcome you for your first session. Next slide.
Hi guys, hi, good morning. I hope you are all right. Okay. Hello guys. Hi. So today's as you can see, our topic is shatter the shackles of generative AI using Llama-2. So let's go towards our agenda. So what is generative AI? I think most of the people will know, but let's go ahead. Generative AI, a deep dive into LLMs, why Llama 2 and live demonstrations. Let's go now. So can anyone tell me what's generative AI? Let's find out, like, okay, anyone? It's yeah, sure. Mm-hmm. Mm-hmm. Yes. So basically, it's very self-explanatory. Like, it's generative AI, right? It's generating something. So it will generate some image, it will generate some audio, it will generate some words, prompts, like anything. So that's like generative AI. So basically, what generative AI is, there are foundation models. So basically, those are the models that Stanford professors have told. Like, before that, we were used to create small models for specifically a certain task. Like, if you want to do certain thing, you will create a small model, and you will create a specific model. So you will, for that, you will create a specific model and you will work on it. But then what researchers have found, like, we will create a large model with large amount of parameters, and they call that foundation model. So what happened, those foundation models were the building block of right now generative AI. So those foundation models helped us to create a large amount of data sets. So those foundation models take a lot of data, like terabytes of data, and they provide a certain output. So what the benefit of those foundation models were, they were very performance effective. Like, rather than creating a small model for specific things, those foundation models were solving a bigger task in a very self-explanatory way. So that was one. So there are three main. So GAN, VAEs, and transformers. So today I think we will more focus on transformers. So anybody in the crowd can tell me about what transformer is? Yeah.
Transformers are basically attention-based model, which use attention and the mechanism, which is different from all those models like CNN, CNN. So it is like SQL query, so it can query more data or large data and generate results.
Yeah. So yes, basically that's the correct answer. So transformers are based on three important things. So encoder, decoder, and attention system. So what does transformer basically do in layman terms? So if you are providing a sequential words, like we are in ChatGPT, we are doing what? We are sending in words, an array of words, and then we get some answer. So what encoder does is it founds the context. So attention is your context, and then it decodes. So it decodes, then it will what do? That it will find the contextual between those contexts that encoder has provided. So then it will decode, and that will provide you. So main difference is the attention. So these are the three important types of models that generative AI is using right now. The most important, then we are LLMs. So now LLMs are the big buzz right now, right? So there are ChatGPT, then there is BART, then there is different also. So LLMs are just used for generating text. So they are most important in generating text. Like you can create poems, you can create code based. So those are the. So what LLMs are, they are a big models, foundation models that are trained basically on a large amount of data. That's mostly articles, web based, and all that. And then they provide, using transformers, they provide some text. So today we are more focusing on that. So basically these are the, you can see generative AI. Then there is natural radiance. So this natural radiance is a foundation models which are more useful in 3D modeling. Then there is diffusion models. I think last session sir has explained the diffusion model stable diffusion, and these are LLMs. So LLMs are two, ChatGPT and Llama, and the Llama 2 is the new extension of Llama. So we will go and learn what is Llama 2 and why we are showing the presentation of it, right? So next, what is Llama 2? So Llama 2, as we have heard, it's a large language model can use for chatbots, right? Llama 2 is trained on human-based data that allows them to replicate human language and even programming, right? So Llama 2 is basically what is it? Let's not read it. It's very. So Llama 2 is basically Facebook wanted to create something for their chatbot because they have Messenger. So like they want to use this generative AI thing into their messaging, and they want to provide something like, alternative to ChatGPT. So what they did is they collaborated with few of the big companies like Microsoft, Oracle, and all this, and they created a model. But what importantly they did, they created that in such a way that it's useful for them to create chatbots and very interactive, immersive experience. Like ChatGPT is not immersive enough. Like you prompt something and it will give you a value, but it's not like it's not immersive. Like a user doesn't interact; it just interacts and then it's like okay, it's very robotic. So what Llama 2 with Llama 2, Facebook wants it's more interactive. Like you are talking to certain an AI that shows you and immerses you, okay, like you are having some kind of conversation on that. So this most important thing, like what is Llama 2? So Llama 2 is an open source. So it's open for commercial use. You can download it from Facebook. So they have provided on meta.ai. So you can download it. It has increased accessibility, diverse application for and innovation. So they have trained on 40% more data than Llama 1. So it's trained on more than 40% of data. It has been very importantly, it's red checked a lot. So like Facebook has identified, like, you have heard like there is lots of articles you find like ChatGPT is like we're thinking as a human. It's like, so that part is in LLMs, that part is known as hallucinations. So what hallucinations are, like you provide some kind of data and then that chat means that model reacts as like hallucinating, like okay, he's alive or like, but that's not real. That's just like it's hallucinating. Then there is lots of misinformation, and then there is lots of biases. So Facebook has done, what they have done is like they have produced a model and red teamed it, so we don't get a lot of misinformation, because misinformation is very big nowadays. Like there is lots of hate crimes and all that, and we really don't want like that to happen. Secondly, then now why Llama 2? Like you will be asking like why Llama 2? Because we already have Bard, we already have ChatGPT, right? So first, Llama 2 is superior on smaller parameters. If you want, like if you have heard, like you can't train if you are working professionals, right? AI, and you want to create your own, let's say, a foundation model. Do you think we can create it without the help of any big large firms like Azure so we can't do that, right? So what Facebook does is on small parameters, they provide a decent and good performance. So like Llama 2 7B model, so there are three models of Llama 2. 7 billion, which is trained on 7 billion parameters, second is on 13 billion parameters, and the third was in 70 billion parameters. So it is trained on 70 billion parameters, and it outperforms ChatGPT 3 on 75 billion parameters. So it demonstrates very great performance in it. So you can use it, like it's a very small model, you can train it on like 15 GB graphic card, you can just immerse it, and then you can go ahead with it. So yeah, as I said, like there are three models. So Facebook has introduced these three. So you can use any of this if you have your infrastructure ready. It's already free. So it's versatile and scalable. So it supports language generation, summarization, questioning, and all that, and capable of processing substantial volumes of data. So it is capable of all the things that you are able to do with Bard and ChatGPT. So continuous improvement. So Llama 2 is continuously improving. So if Meta is already evolving it. So it's like they are doing a lot of reinforcement learning on the model, and you can just download and use that model. So it will be continuously, or you can fine tune it in your own way. And if you can also use your reinforcement learning, and model will be very suitable for that. So this is how their reinforcement. So like there is human feedback, safety rewards, helpful rewards. Then this is fine tuning. So this is what Facebook is doing right now. And this is pre-trained data, self-supervised learning, and Llama 2. So what are pros and cons? So these are the pros. So if it's open source and it's commercial use. So what you can do is like You can use Llama 2 for your needs. You can pre-train it on your desirable. Let's say I want to create a chatbot that is more suitable for medical requirement, right? And in medical requirement, the most important thing is there should not be biases, there should not be like misinformation, there should not be means a lot of uh, leak of information and all that. So you can train this model on your own, and you can provide a certain informative chatbot for basic information, like what if I'm having a flu, what can I do? Like let's say if you are creating a model for mental health too. So basic mental health, people are going from lots of, so you can create a model, and with Llama 2, you can do immersive things, like even add small emotions inside it. So we will show in a demo. No vendor lock-in or forced. So vendor lock-in, as you know, ChatGPT doesn't allow you, it locks in lots of things. Even Google does it. Ability to fine tune, as I've said, you can have the ability to fine tune the model in your way. So that gives us, like as a AI developers, we know like we need to fine tune, like our client will say, or our company needs a fine tune model, we need to use that for a specific task. So you can do that. Model behavior doesn't change. If you have your own model, it adheres to what your needs are. As ChatGPT and BART is like, they're proprietary. They can change their model behavior anytime. If OpenAI wants, it will change the model behavior. If Google wants, they will do that. Tight control over biases and correctness and performance. As I've said, you will have the tight control on the biases and the performance of the model. Now, what are the cons? Not better than ChatGPT in terms of token counts. As you have said, as I've seen. So if you use ChatGPT 3.5, it's already in public domain, or ChatGPT 4, it's not good because it's not trained on that parameters of model. Second, the most important, to load 70 billion model, you need a virtual RAM of 240 GBs, and it's not feasible. Like a lot of people don't afford that because you won't be able to train that model on that. Documentation right now is not sufficient because it's very recent. I think a month old. Facebook has just launched it a month ago. And third is like we don't have the benchmark for the performance against GPT and BART right now. Like what is the performance of 3.5 with versus 3.5 at 4. So let's do a live demonstration. So this is a small, let's do one thing. Let me show you. So basically, let's see. Can you see everything? Everyone see? Or I should zoom in? Everyone can see? Now? Loaded. ના મારા પીસીમાં બંધ થઈ ગયું છે એક સેકન્ડ. ના એ પહેલામાં રન થાય છે એટલે એ પેલું બંધ થઈ ગયું હશે ને એટલેથી.
પોલીસ સ્કૂલોમાં જે કરવું થોડુંક કંઈ થાય તો બાકી ખબર ના હોય ક્લિક ના થાય રાઈટ ક્લિક કરીને કરતા રાઈટ ક્લિક કરીને નતા કરતા
Okay, hello. Meanwhile, they are setting up this. Let's have some conversations. Who among you are belonging to AIML field? Can you just raise your hands? Either working in AIML or enthu working in AIML. Either someone who is bringing business for AIML. Anyone, yeah. We would like to hear something from you related to this topic. If you have heard anything about this, Llama, ChatGPT, Bard, or any other computer vision related things. Anyone? Yes, mate. I think you are. Please share your genuine experience, whatever you are feeling.
Like जहाँ तक मैंने रिसर्च किया है, Llama is more powerful than ChatGPT as per my research, and as a part of working in this field, what I consider is your mathematical power and the logical reasoning part would be very strong. Like कंप्यूटर क्या सोच रहा है वो आपको पहले पता चल जाना चाहिए, तो लाइक आप उसको अच्छे से ट्रेन कर पाओगे. बट लाइक उससे भी पहले वी नीड टू अंडरस्टैंड कि फिर कंप्यूटर काम कैसे करता है. बेसिकली लाइक जहाँ तक मेरे बैचमेट्स है वो लोग लाइक बहुत ही व्हाट डू वी से फोकस्ड है टू अ वेरी पर्टिकुलर थिंग कि लाइक बस सिर्फ कोड काम कर जाना चाहिए. बट लाइक दैट्स नॉट द पार्ट कि कोड के बैक एंड पे क्या काम करता है, दैट ऑल्सो मैटर्स अ लॉट. सो लाइक दिस इज माई पर्सनल एक्सपीरियंस कि फिर लाइक लोगों को वो भी समझना चाहिए कि लाइक कोड के पीछे क्या काम करता है.
True. Very good. What's your name?
सर कौन शुक्ला.
A big round of applause for him, please. What do you do, mate? I just want to know. Are you a student or?
I currently study in my third year doing my specialization in machine learning.
Having such knowledge in your third year of engineering, it really shows how much interested you are towards these technologies.
Thank you so much.
We wish you a very great career.
Thank you so much, sir.
Anyone else who is associated with something like this and would like to speak something? Anyone? From there, from the last row, anyone? Okay, but again, as a positive note, like if many of you are not belonging to AI field and even though you are coming to attend such events, this really shows where the future is heading. So it's again a great sign. Okay, I think we are back with Karan's presentation, so we can resume that now.
Hello. Apologies, guys. I think the server just went off. Okay. So as you can see here, it's normal. Like it will provide you all the information that you need. So like. So it basically works same as ChatGPT. So as you can see, now let's do something different. Okay. So this is you can provide context to this. So let's provide something that. How many of you have aunties who are very sarcastic? Like they will always be sarcastic. Like so, let's do that. Answer every question in a just like Indian sar. sarcastic की स्पेलिंग किसी को आती है तो हाँ CAS okay, is this fine? Okay, now let's see.
Sarcastic people don't just share that identity in first message.
Yeah.
They take some time.
They take some time and they will show. It's not showing. Let's see.
And sarcastic people can be anywhere. Just remove Indian here.
But we want to see Indian, right? Because we will only understand Indian sarcastic aunties because that's we have. Let's see. This. Let's say now if it becomes sarcastic or not. Oh, see, now that's sarcasm.
Karan, wait, Karan, we want you to speak these, read these as well.
I don't have the vibe of that sarcastic.
No, that is
I can't generate it. Like it's not my fault.
Demand from everyone, and if you cannot speak that, find one who can speak that.
Anyone? Deepak bhai, can you speak this?
We need a female candidate.
Anyone?
You have to arrange this.
But I can't do that. Anyone who has that inspiration of being a sarcastic auntie in future?
You have experienced this, so I think you can do it.
But you raise your hand, you raise your hand. That's not fair.
Hiral, please, just read it.
That's like.
I can't roll my eyes. Let me read first.
What did you ask the auntie?
I just asked hello. Hello.
Oh, great. Another one of these hello, how are you conversations. Can't you see I'm busy watching my soap operas and sipping my chai? What do you want, kiddo?
Hiral has a bright future as sarcastic.
That was good.
That's the alchavla kind of a question. See, so that's like everyone can read this. Keep,
People will not accept my tone.
yeah, I know that.
Okay, but I can see that just like Netflix or Amazon Prime, when we are seeing the subtitles, they are sometimes adding such emotions as
Yeah,
well,
so
like,
that's what it's like. It's
roles
more
of eyes.
immersive, you know, as Facebook wants. Like you can do it in different way. Let's if we have done it like in a sarcastic anti way. Let's do it. So this is very familiar. Let's do this.
If anyone has any interesting
Interesting
question,
question.
then please share. Yes. that
And you
will
want to put
make
you want like
easy.
this model to act like in certain way.
Who is the fan of this person XYZ Jarvis from where?
Iron Man.
I am not a big fan of that, so I don't know. Please. Anyone has any question? Good question that we can put
Yeah,
here?
ask Jarvis.
Hyderabadi style is too famous for the Bollywood. Can you?
Mic up on please.
Oh wait.
Question, whoever is asking, just be prepared to help us with some spellings.
Yes.
Nowadays, Bollywood is expensing towards Hyderabadi style. Can you ask something in the Hyderabadi way?
Let's see.
Not properly anti type.
So
that
you want something like in more Hyderabadi way.
Yes.
Just a question in 3-4 words, Tilak. What should we write, man?
Hard to think right now with the holding mic.
Does that works? Let's try.
Let's see how it goes. Jarvis is adjusting his glasses. Oh wow, the multiverse. I excitedly, well, where do I even begin? The only concern is it is sharing too much lengthier messages.
Yes.
Because it is Jarvis.
It's Jarvis. It's his forte. Do you want to read it?
Let's quickly read it so that people can get the actual essence of this. Oh wow, the multiverse. Well, where do I even begin? As an AI assistant with a dash of Hydra tech, I have access to all sorts of, shall we say, interesting information. I'm not an actor, so please expect these things from me. You just go on and... The multiverse, you see, is a vast expanse of infinite realities, each one teeming with their own unique versions of reality, physics, and, dare I say it, Tony Stark? It's like a cosmic library filled with endless possibilities, my dear. And as someone who has been around the block a few times or 10, I can tell you that the sheer scope of it all is simply mind-boggling. But fear not, young one, for though the multiverse may be unfathomable, I have heard this spelling for the first time, there are those among us who have dedicated their lives to exploring its mysteries.
Cough discreetly.
Like certain individuals in this very room, they might just hold the key to unlocking its secrets. Wow. So, what do you think, my curious friend? Are you ready to embark on a journey through the boundless expanse of the multiverse? Or would you rather stick to more, shall we say, conventional means of discovery? The choice is yours, but either way, it promises to be quiet, well, fascinating. Thank you everyone.
Yeah. So I think you got the gist of it, right? So now you can use this model and train it into your specific languages. So there are lots of papers right now that Chinese people are using this model to do a lot of this stuff in Mandarin. So you can also do this into Hindi. So yeah, that was my demonstration. I think it was funny.
It was good.
Yeah.
A big round of applause for him.
Sorry for the technical issue, but yeah, thanks. Thank you.
No, it's fine.
Yeah.
See, hello.
Where did it come?
Is it an alarm or what?
I think Jarvis got alive. I think that evil smirk was real, like
Okay, great. But interestingly, to be honest, I was not knowing anything about Llama and the concept, Jarvis as well, yes. The concept which is explained by Karan. I got to know about Karan that he is having 3+ years of experience in AI/ML. He is very much enthused in learning these things, and Bhavik Bhai from his team has supported and encouraged him really well to come up on the stage and give this beautiful presentation. So this is very good that people are encouraging and supporting those who are interested in these technologies. I'm not against any other technologies. Everything will go, but if something new is coming, we have to adapt it and we have to learn this, and people are doing it. So we encourage more people to learn these things, and our session, our event will be something like this going forward. It's not means the demonstrations which we are showing over here every time is not something that is very well developed and it is there for anyone to grab and present. They have to put their heart, they have to put their blood and sweat into this to present the demo, and servers and all these things takes up a lot of time and lot of effort. So very well done, Karan.
Thank you.
It was nice seeing you and presenting.
Thank you guys, thank you. Hope you have a great day.
Okay, great. Okay, before we start, Karan, you can relax now. Just start that PPT from where you left. Yes, this portion was missed. Any questions? Like any one of you want to question anything about this topic to him? Yes, Tilak.
There is a concept of prompt engineering. Is generative AI a part of a prompt engineering or what?
No, I think not that. I think prompt engineering is more related to like how you are prompting how you are using the generative AI, right?
Okay.
So if what generative AI is like mostly it's a basic, whole subset of like what you are generating and you are providing with AI. So what prompt engineering is doing is like it's trying to answer trying to get a tool to work in a very specific way. So what AI is, it's basically a tool, right? It's as good as a user it is. So if you are a good swordsman, you are a good swordsman. A swordman changed just swordsman, right? So that's what, like prompt engineering will help you to utilize the AI in the best and the most effective way you can use.
Okay, then we can say that prompt engineering is a subset of generative AI, kind of.
I don't think so, but if you create a vague aspect of it, it can be. Like you can say, like, okay, let's understand. You are creating a sword, like, so blacksmithing is different, but learning a sword fighting is different.
Okay.
Like you are using, like, what you are, as blacksmith will develop a sword. So it's generative AI is like it will create, like, there is a, like, you know, a whole subset. There is different kind of models.
Okay. The usage and the learning is two different part over
Yeah.
here.
So
Okay.
you are when you are creating a model, you are not actually working on like how you are going to use it, because that's a totally different from user to user. Prompt engineering is like you will create a prompt on your specific requirement and you. The main what AI developers do is like they take a large chunk of data that's unstructured. You will train your model into it, and then you will fine tune.
Okay.
Yeah.
Thank you.
Any more questions? Thank you, guys.
Okay, good. Thank you. Before we move towards our next session, I have something in between. I want every one of us to speak something, and for that I have a little idea. We all have come up here, and we are all knowing that we are going to an AI meetup, right? So everyone must be having some sort of idea related to AI. My question to everyone is like a mic will roll through to everyone. You all have to stand up. You just have to share your name. We don't need any other details of yours. You just have to give one simple answer to this question. If AI could automate any of your daily routine tasks, what would you choose? Right? This is one of the icebreaker question we have been using like this whenever we are doing such things in our company, in our events. So this is one interaction point for us to start. Again, I'm repeating my question. If AI could automate any one of our routine tasks, whatever we are doing daily, like cleaning our shoes, for an example, washing our cars, our bikes, anything. This is just for your idea to the imagination, right? So let's make something out of it. I'm sure we'll get tons of interesting answers, right? We can start from whoever you like, give mic.
Myself, Puneet. I would like to say that thinking AI can help me in thinking the next part of my mind, like something I would like to do the next step in the near future. So AI can help me sort that thing and come up with a solution. Like if I get stuck in something, a solution to a question which comes up to a mind and helps me in the future. So it will help me in a lot and can solve my solve my problems. Yeah, that's it.
Good, Puneet. Next. Everyone has to speak and everyone has the right to pass mic to anyone. Okay?
Okay, myself Rushabh Tumar, and I like the AI to schedule my every task up to my daily life, like when to take a vacation and everything else.
Myself Sahil, and I would like AI to, the transportation with the help of AI would be very easier. Maybe the accidents can be reduced on road.
True, genuine. Yes, next.
I would like to just model can think like just capture my task from my mind and make a to-do list, because I have a tendency to forget my task, and so if it could help me, it would be better
You
for
are
me
still
to.
a student, don't worry. we forget it in our lives as well.
Sure, sir. Thank you.
Myself, Dhruv. I would like to make music out of AI with prompts.
Okay, good.
Hi, my name is Jaydeep. I would like AI to help me some building my body or something, yeah, so I can lose some weight or something. Thank you.
I have nothing to say. If you want to lose your weight, what should I do?
Myself, Human. I think AI would be better if it attends some of my meetings on my behalf.
That's great, that's great.
Hi, my name is Rakesh. I want AI to sit beside my daughter and have her homework properly done or not. Okay. So that is the main task for me right now. Even I cannot delegate it to, let's say, a tuition teacher or something like that. So there is no such output from the human as well. So I want AI just to do that job.
The thing is, we are now trusting more AI than the human beings.
Exactly.
Hi, I'm Hetal Mehta, and I would like to, AI to answer one of the deadliest questions which I need to answer daily. Bapore jambama શું જોઈએ છે?
That's brilliant, that's great, sir.
Hello everyone, myself Disha. I would like to do AI, my personal behavior analysis, and based on that plan out my day, my finance handling and day-to-day activities, that how can I manage more in good manner. Yeah, thank you.
Hello, myself Shilva Joshi, and I would like to just prioritize my tasks, because nowadays I'm suffering from short-term memory loss. So this is the most important thing for me. Thank you.
This happens with all who are getting more senior into their job role. This happens to everyone.
Myself Nikunj Ganatra, and I would like to use AI to send automatic follow-up reminder to client for a payment.
See, everyone is sharing their personal pains as well, and in one or other way, I think we will have solution to anything in the future.
All of you, I am Ravi Bhatt. If AI automated my things, then firstly I want to do work-life balance and family management.
Family management?
Hello everyone, my name is Lai, and if AI can do a thing for me, I would like to think like AI can tell me the task which I am currently doing. Can it be delegated to someone else?
Looks like you are into management.
No, I am actually a developer right now, but thinking sort of.
Hi, I'm Mansi, and I would like to AI to like what should I wear today, because it's very hectic every morning. Like what should I wear?
I have no answers to this.
Hi, this is Meenakshi, and I want to maintain my monthly expense.
Okay, just a minute. 6583 car number. Whose car is this? 6583. Any one of us? Which car? 6583 number. Anyone's car? It has become a bit blocker for them, so we need to remove it. Baleno, it's Baleno. If it is none of us, then it's fine. 6583 Baleno. Hamari se sir? Okay, let's continue from where we left.
Yeah, I myself Raj.
Yes, myself Pankaj Sudha, and I would like to say AI help us to prepare a good client message, and as well as some PM application, as all that things. So it's very help us in.
Thank you.
Yes, sir.
Hi, Mohit Maru. So I have already a model right now because I'm married. So 50% of my work done by my wife. So automatically. So to understand his requirement and how I get to feel happy to her. So my expectation with my wife to be happy. How can I happy?
Good.
Myself, Saurabh, I want AI to maintain my health like blood report, everything, and answer on behalf of to my wife also.
Okay. Okay, got it.
Hello, myself Siddhi Patel, and I would like AI to communicate and deal with the toxic people around me. And also I want AI to prepare outfits like वो होता है ना, we have so many clothes but do not have the outfits for the everyday like.
Hi all, I am Ravi. So one thing that AI should automate for me is like automating all the formal communications and also remind based on that communication to do or how to take follow because I forgot small details. That's why. Thank you.
Myself Nitin Jetwa, and I would like to stock market में हैंडल करे अकाउंट AI टूल स्टॉक मार्केट में AI टूल है जो अकाउंट हैंडल करे हमारा स्टॉक मार्केट.
Okay, so every day you should be in plus only.
हाँ, yes.
Great.
Yeah, myself Rajendra Patel, and I would like to ask AI to do, fill up the KPI in the sense of like fill up the KPI based on their overall performance and generate the proper output so management can do the appraisal accordingly.
Okay, but again, like I can feel your pain that appraisal is second thing, but the first thing you mentioned is good. KPI, KRS, we all are doing. We are all are filling in most of our companies. So there should be something. It's an interesting thought that a person like a developer should only write his points, and based on those points, if all the KPI and KRS gets filled perfectly by some AI tool, then it can really help everyone. Because nowadays, most of people who are filling the KPI and KRF forms, they are using ChatGPT a lot by giving their exact genuine concerns, not directly from them, but yeah, in one or other way it can help.
Yeah, but if we can
એટલે ટૂલ ની જ વાત કરું છું ટૂલ બની જાય તો સારું ને બધામાં.
Yeah, but if we can track the performance by their points and based on the points they can evaluate them like the KPI averages and all, then it might be helpful.
It can help up to that extent only. Salary is totally different. Okay, next thing.
Thanks. Hello everyone, my name is Vasu Masukia. I want from AI to in day-to-day life to remember take wallet, watch, like this.
Good.
Hello, my name is Nilesh and I want to do AI for me to monitor my daily routines and give me good health tips to maintain my health.
Okay.
Hi, good morning. My name is Krishak and I want AI to plan my daily activities basically for the office routine. Secondly, to spread the positive thoughts in the environment.
Okay, good.
Hello, my name is Ajinkya, and if it is possible, I want AI to print money, then build a machine which teleport me from bed to office directly, and third one is to bring the food which I think in my mind.
Oh my God. That's
Hi, myself Vatsal Shah, and I would like that AI will take my to-do tasks and based on that provide me the smartest solutions with lesser amount of time to get the things done.
Hello, my name is Sahil Koshti and I would like to AI to work as my assistant. Where should I take a break? What should I do in the day-to-day activity so that I can work accordingly?
good.
Hi, myself Keval Vachani.
एंड मैं ये चाहता हूँ कि मेरे जो डेली के डेस्कटॉप टास्क है वो ऑटोमेटिक कर दे एआई.
Hello, myself Meet. I would like to do AI to tips to study and create the manage my life.
ઓકે નાઇસ. યસ, પાછળ લાસ્ટ રૂમમાં કોઈક બાકી રહી ગયા હતા, 3-4 લોકો આઈ થિંક. પછી આપણે આગળવાળાનો ટર્ન લઈએ ફરીવાર. મનદીપ, રસ્તામાં તું તારું કહેતો છે?
Myself Mandeep, I like to do like AI should store my mistakes which I made throughout the day and should inform me at night while I sleep.
In that way your sleep also will get disturbed. Okay, next.
Hello everyone, this is Prasad. I want AI to be a good mentor to make things easy to learn.
Okay, you want AI to be a good mentor to you?
Yeah.
Great, good.
Hello everyone, my name is Navneet. So I want AI to optimize my task and to prioritize my task to do how to do the task and to help me achieve my goals at the end of the day.
Good, nice.
Hello, good morning everyone. My name is Sanjay Desai. So I just want to make AI to help me in my health in my daily routine and to prioritize my health within that.
Okay, good.
Hi, I am Raghav. I want AI to explore the whole world.
You want AI for you to explore the whole world?
Yes, sir.
You don't really want to travel actually there? Okay, now let's start from here. Mandeep wants to pass it to you. I heard it.
Thank you, Mandeep. Thank you, sir. Hello, everyone. Good morning. So I would like सबका काम जो सबने किया वो मेरा AI असिस्टेंट करे.
Cameraman.
Hello, my name is Neeraj Savalia. I would like to using AI to learn AI.
Hello, I am Hiran. So I want AI to develop some sleeping pills so I don't need to sleep. So I just eat those pills.
It means you want to work 24/7, right? Okay, that's great.
So hello, my name is Shubham. So I would like AI to actually manage time for me. Like I have, let's say we have multiple 10 to 12 tasks, right? You need to complete at the end of the day. So find a very optimized plan to actually complete that. So that would be good, right?
Hello, myself Dhruvin. I have seen many of my friends in college time that they are talking to their girlfriends but can't have topic. So they have to cut the call within 30 to 45 minutes. There are many of the friends, they like talk 3 to 4 hours regularly. So how so AI want to create a topic and also conversation, so what to speak.
મારો પણ સેમ ક્વેશ્ચન છે કે છોકરી કહે છે હવે એની આગળ જવાબ શું આપું તો એ જનરેટ કરી નાખો.
Yes, Karan.
If AI can do, if it can help me not to procrastinate, that would be very great. Like I can perform better at my job, or else AI will take my job.
Okay, Karan, the word you use, what is its spelling?
Okay, so procrastination I can't spell, but I can say what the meaning is. Like it's when you are doing something and your mind just diverts itself to something else, which is not productive, and that happens to me a lot.
Procrastination.
Yeah.
Right? Okay, great. Sorry. Okay, next. I'm out of this.
Okay, I want AI to play a most situation making meme whenever a situation occurs to me.
Hello, myself Ox, and I want to from AI debug my daily task and suggest me to where I change in code and this work fine.
Hello, I have Thawal Sangvi and I want AI to remember my daily task. બધું કરી નાખીશ બસ ખાલી મને રિમેમ્બર આપી દે બહુ હોય તો બાજુવાળાને આપી દે.
Hello everyone, myself Pooja Solanki and I just want AI to cook for myself when I'm home.
Hello everyone, myself Kevin Pandya. I want AI to recognize the relative, which mean meet in a family function. Like putte, मैं कौन हूँ? मेरे को क्या पता?
Hello, myself Prasant Thanki. I'm doing SEO basically. So for every day, it's difficult to me find the new content, new keywords, so new title. And I'm a little bit lazy. So I want AI to do all the SEO related tasks on behalf of me. Thanks, I want.
Got it. Hi, I am Jaideep and I want AI to plan out my day. Just
Hello, I am Hiran. I want few LED lights on my head and AI managed to show my temper level that if I am very angry then red, green, yellow like this.
Hello, I'm Komal. There are two things. First, I would like AI to suggest me some good, unique recipes because I'm very picky. Like, this is too spicy, this is too sweet. No, I cannot eat. I take too much time to decide what to eat. So, that would be very helpful. And another thing is, I would like AI to respond on my behalf. So, you want to talk, deal with people, I'll talk to you.
I think we are done with everyone. Okay. Okay. Yes. Akash.
Hello, myself Akash. I would like to AI to invest my money so I can be profitable.
He wants AI to let him become Warren Buffett without doing anything. That's good. That's nice.
Hello, I am Tilak Ved. I would like to organize my R&D and everything to plan my day so that I can learn more things from my job.
Okay, Tilak, good. Great. So it was a great session and we really enjoyed listening this from everyone. If you ask me, I particularly would not like AI to do most of the things you people have said, which is reducing your work. We are having a fear that AI might take up our job. So if you want everything, if you want AI to do everything, our job might be in danger as well, right? People wants to chat automatically. So સામેથી answer automatic જ આવશે. Then there will be no emotions, nothing. We have Llama-2 for emotions. Okay, good. So we are gearing up for our second presentation. Shubham Deyasi is here with his topic. Demystifying CNNs and the role in computer vision. So let's hear it from Shubham and let's gain some fruitful knowledge out of it. Thank you.
Morning guys, am I audible? Okay, so let's get this show on the road. So first of all, let's talk about, so what are we going to talk about today? So let's go through the agenda real quick. So we have CNN, then we have why are we using CNNs? And then we have basic architecture, various architectures of CNNs. Then we have application of CNN, and then we will have some live demos of kernels as well as CNN actually going through. Okay, so what are CNNs? So to be brief, let me first unabbreviate it. So it's convolution neural networks. So everyone, I think in AI, wherever you do is neural networks, right? So how is it different and what is it based out of, right? So let's say whenever you perceive image data, like whenever you see things, right? So what happens in a human brain is like you see something, then you capture that image data and it goes to your visual cortex of your brain, and then it processes something, right? So this concept of actually taking that image and going to your brain for actually processing it, so that is the concept of CNN. So same thing. So it is inspired by the visual cortex and it is used for the perception of visual data. So good thing about CNNs is the amount of finding patterns, right? Let's say whenever I look at a person, I don't know that is a person until and unless I can see a figure of that person. So you see let's say it is a very dark environment and then you see a silhouette of a person. So you know that is a person, right? Because you recognize that this is how a person will look, right? So therefore it is a person. Okay. So why CNNs? Specifically how it finds the patterns, and if you look at this demo, so means like why should we learn CNNs first of all, right? So CNNs visual data, right? We have our visual data, and with that visual data, what can you do? Like let's say I just give you an example, like if you see a silhouette of a person, you know that is a person itself, right? So same thing. We can use that data to actually recognize something. Like let's say right now here a car is being tracked, right? So you can see that cars are moving on and you can count the cars, you can track the cars, right? So another thing, so this is what we call object detection and tracking, right? This is a simple example of classification. Let's say you give it a dog or a cat. You see an animal on the street, obviously, let's say it is either a cat or a dog. So you recognize it as a cat or a dog, right? So that is also possible by a CNN. And another thing that you see here, so this is what we have a very famous data set called MNIST data set, which actually recognizes handwritten digits. Like you write 1, 2, 3 by yourself, and it can recognize that what it is. So if you look here, see you see a 3 here, so it gives a percentage of 3. So we'll come into it, we'll discuss on it. So how does a CNN actually look like? So this is the basic architecture of a CNN. So you have an input, which is obviously the visual data that we see, right? And then we have something called a convolution layer, and then we have something called pooling, and then we have the fully connected layer, which helps us in classification. Okay, so first 3 layers that we have, so those are for feature extraction. Like just I mentioned like a silhouette of a person, right? So you see that the person is something like this, or let's say you see a fan or a TV or something like that. So you first see that it is actually a TV, it looks like this, right? So yeah. So the first part that we have is the feature extraction part, and then we have something that will actually classify it, what this thing is actually, right? Okay. So this is the actually how a CNN actually looks like. So this was a very small part. So this is how a total CNN looks like. So like you have many convolution and pooling layers, pooling layers, and this goes on, depends on the architecture of the CNN. Okay. So feature extraction, let's talk about features especially. And let's say we are just taking into consideration the MNIST dataset that we are talking about, the handwritten digits. Okay, let's say I want to classify a 9. So if you try to find a pattern within these, so what can you see? You see a 1 circle and 1 line. So if you take these patterns like, so this can make up a 9. For I need 2 O's, but one will be on the top side, one will be on the bottom side, right? And like 4 you need 1 line which is almost similar to this one, and then you need another one which is almost here, and then you need a dash or something like that. So these are how features will be extracted, and I'll give you some demos of features. Like let's say this is a neural network of an MNIST neural network which does classification of digits. Like for 9, you can see these are the various features that get extracted. So these many layers you see 1, 2, 3, 4. So these are part of these layers, right? So how these are actually, which features are actually going to get extracted. So this is for 9. I have all the digits here, means how the digits will actually look like, means after a certain period of time, right? 3, 2, and 1, 0. Okay. So we got the point that convolution, the first layer that is there, it will be helpful in extracting features. Now, how actually the features actually get extracted? So there has to be some kind of maths or some kind of a technique by which we can extract the features actually, right? Okay, so we'll discuss the first part of the feature. We had three parts in it, right? If you remember. So one was convolution, and then was something called ReLU, which was the activation function, and then we had something called the pooling layer. So we'll first discuss the first layer, the convolution layer itself. So if you look at this, so generally convolution happens in 1D, 2D, 3D, but for image data, we just need the 2D one. Okay. So if you look at this, just look at the movement of this. Forget everything and just think of the movement that this is happening. And if it is moving, like this is a 5x5 matrix, right? But before that, just imagine an image, right? If you see an image, so obviously, how will you perceive that data itself? Let's say a black and white image, right? If you take a pixel, the pixel is going to have some values, right? So the value is going to be between 0 to 255 because we have an 8-bit image, right? And if it can range from grayscale image to a 3-channel image, like an RGB image also. Yeah. So those are the values that you actually get represented here. This 12, 12, 17. These are the pixel values that we have, right? It can be normalized, it can be unnormalized as well. So this here is just a demo of like how the convolution is actually working. No real values here. Okay. So this you see how actually the pattern moves on. Okay. So what was happening in this pattern, if you look at it carefully, so we have 3 and there was something here with which we multiplied and we got something here. So what was actually happening is, let's look at this here. So let's say 1 and 0, so this is my input. This is let's say a black and white image. Let's say 0 represents the black fields and 1 represents the bright fields. Okay. So what is going to, so I have a patch of let's say 3, the total is 5 by 5 and I take a patch of 3 by 3 and then I have a kernel, which is actually the main thing that actually helps us in extracting features. Different kernels give us different features, right? Then we okay, so we do a multiplication with the kernel and then we get some value. So this value has to have some meaning, right? So we'll come into that. I'll show you a demo on the how kernels can actually extract each and every feature. But first we go through how this convolution layer actually works. Okay. So if you see here, so there is, if you look at this image, do you feel there is something different about it than this previous image that we had? I'll just go to this image once. Do you see anything is different? Or is it just same? Do you feel is it same or is it different? It is different. So if you look at it close enough, so what you see is it is actually skipping 2, right? So this is something what we call striding. Like let's say I don't want all my features to be extracted. I want to diminish some features also. So what happens is actually when we have like let's say I have a 512 plus 512 image. So how many points do I have? 512 to the power 2. So those are too many points. And if I let's say talk about around, if I do this thing around like 4 times, so I have that many times to compute actually. So that increases computation also, right? We want to train a model, but we don't want to do it at such an expense, right? It is very computationally expensive, right? So what we are going to do, we are going to reduce some features, right? So for that we are using striding. There is another technique which actually helps with that also, that is pooling layer, but we'll come into that. So, but this will also help us reduce the features, right? There's another thing what we use in convolution, that is something called padding, right? So this was my real image, then we have 0. If you look at the convolution, let me go through this. If you look at the convolution, so just pick this line 301. So if you look at it, it gets means like the operation happens on that column twice. If you look at it carefully, once when the cube is here, just give me just a second, once and twice. That happens twice, right? But if you just look at the layer on the outer side, it just happens once. So we need, means like the features on the edges of the image, those are neglected at some point because you go 1, 2, 3. So those corners are going to be neglected. So for that, what we have is padding. So I do it, I put an extra layer of black pixels here, and then therefore this one also happens twice. So it is better, right? But the center one happens thrice. But that is fine because what will happen is like my image that's gonna shrink down will have features of the center one more, but of the outer sides less. So this is, I'll just explain the filter. So this is a picture of a dog. If I use this kernel, so the picture of the dog actually sharpens. And if I use this filter, the picture of the dog actually blurs out. So those many filters that you have in your phones, on your Snapchats, on your Instagram, everyone uses a part of a kernel, right? So there are different kernels that take into consideration different things. Okay, let me just show you a demo of the kernels. Is it quite visible here? Okay, so this was the real image that was there. This is a picture of a guy, and it is a very small picture, I think 32 by 32 pixels. And the thing that you see here, the values on the left, the right side is actually the image if it is broadened up, and on the left you see the values of the pixels, like it is a black and white image. So 0 to 255, 0 represents your fully black image, 255 represents your wholly white image. Okay, so then we have, this is the kernel. This is the same kernel that we saw on that dog, right, to sharpen that image, right? So this is the output of that image that we get. So you see that the eyes are sharpened, the mouth is sharpened, the values that are there. Let's say I want to do a custom kernel, and you see another, this one, right? Let me just put it in. Okay, so this is the original image. Let's say I want to detect the vertical lines or the horizontal lines. Let's say I'll put a custom matrix here. So this is how actually features get extracted. Like let's say this, I want to detect the edges of a particular thing. So right now what you can see is just the vertical lines getting detected, right? Let's say I want to change this to and detect only the horizontal lines. You see, this is just the horizontal lines. And how this happens is this kernel that I showed you, and this get convolved over the network, and the answer we get it. So you first of all got the how that multiplication actually happens, right? We have a 3x3 matrix that goes into this, and then we get just one output, right? There are different kind of kernels. Let's say I'll do the blur one that we just saw, right? So you see the blurriness here, right? So what it does is actually takes all of the values here, and then we have 9 pixels, right? And then it takes all the values and does an average on that, right? We could do a direct averaging, but instead of that, here what we are using is something called the Gaussian blur. So if you look at the kernel values, 0.25, 0.065. So if you look at the center has the highest value, and the adjacent ones have higher values than the corner ones, right? So what it tells the image is actually focus on the center. The weightage of the center pixel is more than the weightage of the outer pixels, and therefore you get a blurring effect. Okay, so you got the concept how filters actually help in getting specific features, right? So after convolution, so how does this whole thing actually fit into the whole architecture, right? I just explained to you how kernels work, how convolution actually works right now. Let's say what you see here is a RGB image. So there it's going to have like 3 channels, RG and B. And let's say you take one kernel, like you will have multiple kernels, but let's just discuss for one single kernel. Okay, you have three images, three, what do you say, channels, and then you do a convolution, and you will get something like this, 1, 2, 3, right? This is a 5x5 image, and the kernel size is 3x2. So 5 minus 3 plus 1 will result in 3. So we have a value of 3 by 3. And after that, what are we going to do? We are going to add these three together, and then we get a value. And after that, we add a bias term. Like, so what this is going to do, it is going to tell us how much threshold the neuron is actually going to get activated. If you remember, after this we had convolution, then we had something called ReLU. So what is a ReLU? So this is a type of an activation function. All activation functions are there to actually integrate non-linearity into the equation. Let's say I do some addition here, and after some time then again I do some addition. So it is a linear equation plus linear equation plus linear equation. The whole thing is going to be linear, right? So to put some non-linearity within that, we send in an activation function. So ReLU is the most common one, like there is one very most common question, like which activation function to actually use, right? So there are a couple of ones that we have for some fixed categories, but if we don't, like we do it as a try and error. So the first one that comes into mind is ReLU. So what the ReLU activation function actually does is, like you have a value, let's say you have some value, and let's say -2, and then if you want to put it through a ReLU function, so it will give you 0. Anything less than 0 will give output it as 0, anything more than 0 will be same as that. Okay, so let's talk about pooling. So if you look at the layer here, so what happened, this 3 got converged and got into 1 pixel, right? And if you look at this picture, so there are a couple of pixels here that got narrowed down to 1 pixel. So why is that? So first of all, pooling helps us in actually reducing the number of data that we have, right? So let's say I had a 512 plus 512 image, just like I explained before. So we have too many features to actually compute, right? And we want to shrink it down, right? So there we have the pooling layer, which actually does it. Let's say this is an image of, let's say, 4 by 4. And what I did was I put a pooling layer of stride, a kernel size of 2, like 2 by 2. So what this is going to do, it's going to take this value and give one value. Then this 4 values give one value, 4 values, 1 value, 4 values, 1 value. So how do we get that value? In the convolution layer, we used to do a multiplication with the kernel and then add it and get a value, right? Instead here, what we do is we don't do any multiplication or something. We have two techniques here. One is max pooling and one is average pooling. Like let's say I have these 4 values. So what is the maximum out of it? It is 9. So we have here, after 210, this is 2, this is 5, sorry, this is 6, and this is 3. So we took the maximum values of the grade, right? This is the average pooling. So the average of this is 4, the average of this is 1, 4, and 2. So what this actually does is, so it keeps the important features and it actually reduces the complexity also. But how do you know which pooling layer is going to keep which important feature? So that depends on the convolution layer that you used before it. Because when you are going to make an architecture by yourself, you know what layers are going to give what kind of outputs, right? So I'll just give see the example here. Let's say after convolution, I got this as my input or this as my input, and if I change the pooling accordingly, so the value actually changes. Let's say if I take an input feature map of, let's say my input feature map comes out to be something like this. So still remember that black is 0 and white is 255, right? So if I do a max of 255 and 0, and let's say you have surrounding pixels of 255 and then you have 4 zeros, 3 zeros, taking a 2 by 2 kernel. So what is the output? The output is going to be 255, right? So you get a white, fully white surface. So your features are all gone. So it depends on your features how it is going to be. Let's say for if I do an average pooling here, so 255 plus 0 plus 0 plus 0 divided by 4 is going to give something which is not fully black or fully white, right? It's going to be something like gray, right? Same thing goes for here. Let's say I have a feature map which actually gives me something like this. I have a black surface with a white. If I do max pooling here, then I'll get I'll keep that white line. It's going to be shrinked, but it's going to still be there, right? If I do an average pooling here, so it's going to give me 0, right? Because it's going to shrink it too much, right? So this is one very good video that actually helps us in understanding the convolution and the pooling, right? Play that. So this guy first shredded the image of a dog, and then he is evenly splitting the pixels. But what you can still So what you can see here is evenly splitting the dog photo, and then it still holds similarity of the dog. You can still recognize that this is a dog, even if it is not the full image. You have almost half of the pixels gone, right? And it has been torn into pieces. Now he's going to again shred it, and this time we shredded it vertically. Right now he's going to shred it horizontally. So he is again evenly splitting the image of the dog. And this is the resulting image that we get. If you look at it, we right now have 4 photos of dog from just one photo. And each of them has 1/4 the pixel. But you are still able to recognize that this is a dog. This may be a dog, right? Because you see the means like the silhouette of the dog, right? It looks like a dog. So that is what convolution is all about. It does not need to see the whole thing, but it will reduce and take the features, and it will tell that there is a possibility that this is a dog, right? Okay, so we have gone through convolution, then we have gone through max pooling also. Okay, so let me summarize this a bit. You see an image of 28 cross 28 cross 1. So 1 means there is one channel, so that is a grayscale image. And the amount of pixels that we have, the dimensions of the image is 28 by 28. Then we do a convolution, and it turns down into 24 cross 24, right? With how many channels? N1. So that is the N1 is the number of kernels that we have. So if we do one kernel, then I'll get 24 cross 24 cross 1. That is one kernel output. Then I do a second kernel output, which will result me in 24 cross 24 cross 1. And then I stack them all. Then I stack them all together. So it becomes a depth of N1, right? So 24 cross 24 cross N1, right? And then what I do is I do a pooling. So a pooling does not change the number of the amount of depth we have, but actually reduces the number of pixels in a particular particular frame. So it reduced it from 24 to 24 to 12 cross 12. So right now still we have N1, right? Then after that, what I do, I again do a convolution, and right now I say the amount of channels I want is N2. So what is gonna do? It's gonna do 8 cross 8 cross N2. So that as the convolution goes on, the size diminishes and the depth actually increases, right? After that, we have something like this. Let's say the output comes out to something called 4 cross 4 cross N2. After that, what we do? So our features have been extracted. So we know that these N2 channels that have been there, so they are going to contain some features regarding the image that we have put inside, right? So feature extraction has been done. So after that, we have something called the fully connected layer, which will actually help us classify it, right? So we have the numbers here, like, so if I calculate the whole number, so this is going to be 16N2, right? And if I then flatten it out, so this will become data, this will have some, we'll send each of this data to some points, like this is N3 units. So this N3 units is going to be 4 cross 4 into N2. So I'll show basic input, so how the fully connected layer will look like. So we flattened out all the data, right? And every data that we have, we'll put it into, let's say, an input layer. We'll have multiple input layers depending on how many outputs we get from the feature extractor. And then we'll run it through a fully convolution neural network, and here I'll get the output at what the value is going to be. Let's say if I put in a value of 9, so the output here should be that I get a 100% confidence of 9 or 100% confidence of 8. Okay. So the output from here goes as an input for this, right? So how does one unit here or one unit here looks like? So I have one, what do you say? This is what you call the basic unit of a neural network, right? So this is a perceptron, and then what happens is here I am explaining one of these, right? And then you take input from 2 with some weightage, and then you get an output, right? So what this is going to do is like, let's say I have 100 features, and then I have, let's say, 10 of these hidden layers. Okay, 10 nodes, and one node is going to look something like this. Like it's going to take one feature, 100 features, like x1 w1 plus x2 w2 plus x3 w3, and then it's going to get added with a bias, just like what we had in the convolution layer. So first the addition, then we'll have an activation layer, then it's going to give an output, and this thing repeats on. Same thing has been shown here. Like you have your weights come in, and then this will do a summation, and then we'll have a activation, which will actually put nonlinearity into the equation itself. So another thing, like whenever we get, let's say we have 4 layers, and then we have some output, right? So after that output, you need to, let's say you get some values out of, let's say 1 and 100 or something like that. So you need to now again classify it, right? So anyone with the maximum value will be actually that, right? So for classification, we use what is called the softmax function. Like let's say 1, 1.3, 5.1, 2.2, and 0.7 and 1.1. So this is the output that you actually get, right? So with that, you don't know this is what, this is a 1, this is a 2, or this is a 3. So you need to put the whole thing within a range of 0 and 1 so that you can get the probability. What is the probability that this is a 1? What is the probability that this is a 2? Right. So for this, what we do is the averaging function that we do, the probability function that we use, that is the softmax function that we use, right? So if you see, like if you add this all up, then you do 1.3 divided by the whole thing, so you'll get some value. But that is also average, right? That is the ratio. But this ratio works better compared to that, because this takes into consideration the log function as well. So if you see, if I do a 5 point, if the value is 5.1, so what is the probability? The probability is 0.9, right? So likewise, like if the value is 1.3, the probability is 0.2, right? The lower the value, lower the probability, right? So it does, this is a function that's actually computes this one, right? So this CNN that I just explained, the whole flow that I explained, right? So this is a very good one that we can actually move into. Like let's say the digit recognizer, like the one that was explaining, like if it can recognize 1, 2, 3 and whatever. Let's say I'll draw something. Let's say I'll draw 1. It looks like a 1 to me, and the prediction is 1 with a confidence of 63.97. Let's say put in a line here. What's it gonna predict? Still a 1. This predicts it as 3, but looks like a 7. We got a 7, right? So you see how the inputs actually go in and how it actually predicts it, right? I'll show you a demo which actually shows the features itself that actually gets extracted. So this is a classification. This is a classification of a couple of classes. You see the output classes here. We have. It's not visible, I guess so. दिख रहा? So we have a couple of things here. So yeah. So this is a live board, ladybug, pizza, bell pepper, school bus, koala, espresso, red panda, orange, and sports car. So these are the classes that it can output as. And here are some of the, what do you say, sample images that we have, right? Let's say I put in a sports car. It gets split into 3 channels like red, green, and blue, and then it outputs as sports car, right? We can see all the layers that actually happening. So if you want to look at the convolution layer of the first convolution layer. So you see here, right? So this convolution is actually happening here, and then it gets added with the bias itself, and then the feature is extracted itself, right? And then we have an ReLU activation function which actually transfers this whole thing. You see all the negative values, the red one here. These are actually the negative values, and then when it goes through the ReLU activation function, it becomes as positive, and you see that these red ones are gone here, right? Same thing goes for different layers. See the same thing happening here. So you can see the convolution actually happening here. So this is an input image of 62 by 62 and the output is 60. So we have a kernel size of 3. You can see the kernel values here as well. You can as well play with it and you can understand actually what is happening. So this is the thing that we explained. So the value of the pixel gets actually multiplied with the kernel value, and then it outputs a value which looks like this. Have a look at this max pooling layer. You see the pixels actually here, and then when it takes only the maximum, so only the features are available here. Specific pixels only. And if you look at this, this is this is the last layer of the convolution. If you look at this, the features are almost unrecognizable by human eyes. You don't get a feel of actually what is getting detected, right? But instead, if you look at the features on the beginning, so you get a feel like what the kernel is actually trying to detect. Like it is getting a silhouette of what this is, right? You can see the edge is getting detected, right? Okay, moving forward, let's look at some of the initial stages of when CNN was actually developed. Let's discuss some architectures on that. So this is a common one that we have. This is one of the first CNN architectures that was ever made, the LENET 5, right? So you see an input image of 32 cross 32, means that 32 by 32 cross 1 pixel, means there is a grayscale image, right? And goes through one convolution layer, then one pooling layer, convolution, pooling, and then we have a fully connected layer that actually takes place, right? And so this shows actually the reduction in layers. So when you have convolution, the depth increased to 6. Then we have pooling, depth remained same, but the image size actually got reduced. Same goes for again convolution, pixel size reduced, and the depth almost increased by 3 times. and then we have something like 5 cross 5 cross 16. From here we went to this. So this part is the feature extraction, and this part that we have is which will actually do the classification that we have, right? So this is the AlexNet architecture. It was developed right after LLMs, right? So this takes an image of 244 cross 244 with 3. This is means like an RGB image, and then it goes through 55 cross 96. The depth increases, depth remains same. So this is a max pooling layer that we have, and then we have the fully connected layer. So this is another one. This is VG16. That is one of the most famous one that we. This is an old one, but it's still one of the most popular ones that we use till now. Same thing. 224 cross. This takes a bigger image. Like apart from this one, this takes a very small image, like 32 cross 32. This one and this one has a relatively bigger input size. So these are your convolution neural networks. Then we have pull down. Then we have again convolution, and as you look at this architecture, you see the depth actually getting increased, right? And the height and weight actually getting reduced, right? So then we have the output seems to be something like at the last the output seems to be 7 cross 7 cross 512. So this is the end features that we get, and those are going to be used for our fully connected layer that is here. So we went through almost all of the phases of CNNs, right? So now what do we want to do with the CNNs? We got the CNN, right? We got the output features right now. So the first thing that we explained before, right? It was for object detection, object segmentation. So these are some of the applications of it. Even for NLP, for speech recognition, we also use convolution. So that is a wholly different domain altogether. So, and after image detection, image classification, you have a couple of things that you can do. Like you can count objects, you can track objects, you can track a person, you can count the number of vehicles, you can calculate speed, multiple different applications depending on business needs, right? And there are still some challenges that we still want to do today, right? You cannot always do inference on the cloud. Let's say you want to build some real-time system. Like I am capturing, there is a human here. I want to get him detected here, and I'm to send him real-time information, right? You cannot sell the whole data to the cloud and then process it. So it's going to take time, right? So for that, what we do is something called the edge detection, right? So we can compute it on a small device that is located here, and therefore we can get real-time inferences, right? But to still do that, we need good architectures and good models which can work on low power as well as low computation, right? So the first thing that we discussed in CNN was how it was computationally more expensive, and that's why what we put in stacking layers as well as pooling layers to actually make it less computationally expensive, right? So one thing that we do is one of the most hard challenges is having powerful hardware. You cannot have powerful hardware anywhere. We can have cloud GPUs, but on edge we can't have that. So what we do is, like whatever model that we have, we optimize it so that it can run on small hardware. The model size becomes less, as well as it can run more optimally on GPUs. Okay. So one of the things that is continuously going on is on model compression and optimization, so that we can run it on mobile devices as well. So we can make it faster. We can run it in real time. So yeah, and another thing for running in mobile devices, you can't use the same kind of, the architecture is going to be still the same, but you need to change the model format so that it can run it optimally on that. And like we have two very famous formats that we generally use, the ONNX and the TensorRT. So, and it is not such that you can convert any model into ONNX or TensorRT, because the layers and the pooling layers and the architecture that we have is slightly different from it. We need to change some layers into it, then only we can convert it into this. So most of the challenges that we face today is mostly based on this. So we have good models already on the market, but they are very huge. We need to make it shorter, make it faster, right? So we can run it on mobile devices. Like the same thing goes on your phone as well. So you can you can run your models on your phone as well. But if you look at the applications that are available today, it is very sticky. It uses a lot of computational power, and there are some very specific things that has to be, the requirements has to be met to actually run it on your phone. So this brings us to the end of our CNN. So if you have any questions, let's get into it. Mic to the.
Sir, actually, on that website where we tested the photo of 32 cross 32, there was a filter matrix. When the numbers were 0.0625, 0.125, when the center number was 0.25.
Yes.
So like when I noticed the pattern, the corner numbers were exactly 1/4 of the center number. So like, is there any pattern to it, or it's a like something specific to it?
Yeah, so the pattern that I actually told you was that is about something called the Gaussian blur. So the Gaussian blur has a pattern of 3D. If you look at a normal binomial distribution, it looks something like this. The center one has the highest value, whereas the value actually goes on reducing, right? So that is actually what I showed you, and what it actually means is like the center pixel has the highest, what do you say, weightage. Like I could show you on that. Give me a second. You're talking about this, right?
Yes.
Yeah. So I'll show you a thing before this. Let's say we want to compute everything as the same weightage, 1/9. If you look at this kernel, this is also blurring it, right?
Yeah.
Yes. So what I'm telling it to do is actually take 9 pixels around it and do an average on that pixel, right? But this gives us blurring, no issues, no problem with that also. But sometimes what happens is when you take this kernel size and increase this kernel size, so the blurriness becomes too much and you can't actually differentiate the actual features. So that's why we use something like this, the Gaussian blur, which actually tells us is, okay, which actually tells us the center pixel that I'm concentrating most on will have the most weightage instead of that. Yes, you can actually change the Gaussian blur constants and actually look for yourself like which kind of blur is actually suitable for your application itself. Does that answer your question?
Yes, sir.
Okay. Anyone else? No questions? The presentation was so good? Or did it all go over your head? There can be two scenes only when you have no questions. No questions, anyone? Okay, so then we'll wrap it up for today. Thank you very much.
Okay, all right. Thank you very much, Shubham. It was great learning about highly technological things from you. It was very mathematical as well. So a lot of things were going on top of my head. But I think some of us must have feel this. This was a technical session we intentionally kept in this event, and Shubham did brilliantly for this. Again, a big round of applause for him. Yes. Right. So we are at the closing part of this event. We have something to share as Hiren is with us, like he's our tech lead in AIML. So we were discussing and he Okay, he will share his part later. Hiren will come and he will share some of his thoughts he wanted to share after this topic gets over. So the thing is, like, since last two times we have been arranging this meetup, but what next is coming in this meetups? That is something my colleague Hiral would like to explain to all of us about this. Hiral, welcome.
Thank you, sir. Okay. First of all, I would like to know about you guys. Just raise your hand. How many from you are a non-AI people who is not working in AI? કે જેને AI સાથે કાંઈ લેવા દેવા નથી. Still here. I will not ask any questions, so feel free to raise your hand. Okay. જેને દૂર દૂર સુધી AI સાથે કાંઈ જ લાગતું ઓળખતું નથી. એવા પીપલ કે જે લોકો AI સાથે વર્ક નથી કરતા પણ થોડું થોડું કનેક્શન છે, કે ડાયરેક્ટલી ડેવલપમેન્ટ નથી કરતા પણ AI જોડે કનેક્શન છે, અને એવા લોકો કે જે આઈધર સ્ટડી કરે છે ઓર એઆઈમાં વર્ક કરે છે. ધેટ્સ ગ્રેટ. ઓકે, આપણે આપણી સેકન્ડ મીટઅપ છે. લાસ્ટ 2 મીટઅપથી એઝ વેલ એની પહેલાંથી આ વસ્તુ એક અમે ઓબ્ઝર્વ કરી છે કે વી હેવ મેની પીપલ હુ વોન્ટ્સ ટુ નો મોર અબાઉટ એઆઈ, રાઈટ? ઇન માર્કેટ ઇવન દેર ઇઝ અ લોટ્સ ઓફ પીપલ કે જેને એઆઈ વિશે નોલેજ જોઈએ છે. એટ સમ લેવલ આપણી પાસે એવા લોકો પણ છે કે જે એઆઈમાં વર્ક કરે છે, એઆઈના કોઈ એક ટોપિકમાં, અથવા તો એની કોઈ એક પર્ટિક્યુલર ફિલ્ડમાં કીન છે, અથવા તો ડે ટુ ડે એ લોકો એઆઈ સાથે કનેક્ટેડ છે, રાઈટ? સો આપણી પાસે બે ટાઈપના લોકો છે, બટ વી ડોન્ટ હેવ એની પ્લેટફોર્મ કે જ્યાં ઇન્ટેન્શનલી બધા સાથે મળી અને આવી રીતે મીટઅપ કરી શકીએ ઓર એનીથિંગ એલ્સ, રાઈટ? સો આપણો ગોલ એ હતો કે ટુ લર્ન ટુગેધર એન્ડ ગ્રો ટુગેધર. એક મને જે આવડે છે હું તમને શીખવાડું, તમને જે આવડે છે તમે મને બતાવો. આ રીતે આપણે એઆઈમાં એક સાથે આગળ વધી શકીએ. ડઝન્ટ મેટર હું એઆઈ બેકગ્રાઉન્ડમાંથી છું કે નહીં, રાઈટ? સો આ ગોલથી લઈ અને આપણે લાસ્ટ એઆઈ અપ્રિસિએશન ડેના દિવસે મીટઅપ સ્ટાર્ટ કરી હતી એન્ડ આજે આપણે એને કન્ટિન્યુ કરી, રાઈટ? સો ધીસ મીટઅપ વર હોસ્ટેડ બાય આઈટી પાથ એન્ડ ઓર્ગેનાઇઝડ બાય વેબોકલ ટેકનોલોજી, રાઈટ? બટ વોટ નેક્સ્ટ? આ વસ્તુમાં એક લિમિટેશન આવી કે ફોર વન ડે, ફોર એની રીઝન વેબોકલ ટેકનોલોજી પાસે લેટ્સ સે એક્સ નંબર ઓફ ડેવલપર્સ છે, એઆઈ ડેવલપર્સ છે, બટ એ લોકો ઓર્ગેનાઇઝ કરે છે ફ્રોમ ધ અનધર પીપલ કે એને કંઈક બીજું શીખવું છે, એની પાસે કંઈક અધર આઈડિયાઝ છે. કોઈ 3G કંપની આવી, એની પાસે કોઈ મોટું એઆઈ ડેવલપરનું પૂલ છે. કોઈ એવા લોકો છે કે જેને આની કંઈ ઇન્ફોર્મેશન જ નથી કે અહીંયા અમદાવાદમાં આ જગ્યાએ આવું કંઈક થાય છે, રાઈટ? સો અત્યારે આપણે જે કરીએ છીએ દેટ ઇઝ નોટ સ્કેલેબલ. વી આર બાઉન્ડેડ વિથ સમથિંગ બિકોઝ વી આર ડુઈંગ બેઝડ ઓન વન or two organization, that is Webocult and IT Path Solution, right? But now what we want to do, we want to expand. We want to create one community where not Webocult or not IT Path or not even any organization will organize this event. Now onwards me or you, we will organize this event, right? આજે હોસ્ટ હાર્દિક સર કરે છે, કોઈ વેબોકલના ડેવલપરે સ્પીચ આપી, કોઈ આઈટી પાથના ડેવલપરે એઝ અ સ્પીકર હતા. બટ કાલથી એવું નહીં હોય. કલ કોઈ ઓર આएगा, નગમો કી ખિલતી કલિયા ચુનને વાલે, મુझसे बेहतर कहने वाले, तुझसे बेहतर सुनने वाले, राइट? सो बेर विथ माय इंग्लिश. ઓકે, સો આ વસ્તુ કરવા માટે, સ્કેલેબલ થવા માટે, વી આર ગોઈંગ ટુ સ્ટાર્ટ વન કમ્યુનિટી and that is AI Vision Community India. Please give a big round of applause for it. So our tagline is connecting innovators in computer vision and Age AI. Mainly we will focus on these two topics, that is computer vision and Age AI, right? And our one and only goal is to learn together, to grow together. Okay? Right now we are in a very first step of this community. So today we are just starting this community, and if you want to join, then you can join via this WhatsApp group. Further we will create some LinkedIn pages and all these things, groups, and we'll do it together, right? But to start something as a part of first steps, I would request everyone to join. If you would like to attend this type of meetups in future, then you can join this community. Another thing, if any individual have any topics to present or any topics in mind that I don't know about this topic, but I would like to know more about this topic. So you can submit your topics, you can submit your name as a speaker. If you have any ideas that આપણે as a community કંઈક આ રીતે કરી શકીએ, આ રીતે build કરી શકીએ, I saw something કે આવું ક્યાંક થાય છે, આપણે આવું કરવું જોઈએ, any type of raw ideas, you can share with me. You can connect to me on LinkedIn or WhatsApp, anywhere. You can talk with me and together we will build this community. Okay? Please join this. If anyone cannot scan, then please help Bhumika. Okay, fine. Okay. Yes, I would like to invite Hiren to share the one thing regarding this community.
So yeah, recently what problem I am seeing mostly in the Gujarat community is AI. Like most of the developers are mobile developers, web developers. They want to use AI models, but they don't have ready to use AI models. They have to take help of other people or someone who is expert in AI, so they can integrate those models in their mobile or website or anywhere, right? So we are building one open source code base also, where we will plan like 100 or hundreds of models free to use for anyone, and it won't be bounded to the language. If you are in .NET, it's fine. If you are in C#, if you are in Go, JavaScript, whatever language you use, whatever framework you use, you can easily use those models. So we are building that repository also in a community, and other developers who are working in AI, they can also contribute and send their models, and we will optimize those models to run on mobile and web devices. So that's also we are going to do in part of this community.
Thank you, Hiren. Okay, before further proceed, I would like to mention two things that as a community, we never support or we never motivate any things which is not aligned with our goal. Our goal is learn and grow together. Another activities like branding, HR activity or any other activity, we will never promote or never be part of these activities. Okay, thank you.
Thank you very much, Hiral and Hiren, both for this announcement. Guys, it is really a very big announcement. We might not be able to understand this at this moment, but if I take a look at next 6 months, and if such 6 events will be done by this community and the knowledge sharing that would be happening, it will be tremendously helpful for everyone. Right? So summarizing again the things, we have this community, AI Vision Community India now, will be hosting such events. Anyone from you or your friends, whoever wants to be a speaker right now, Hiral is there, our team is there. Volunteers, if you want to join them, you can contact Hiral and be a part of this. This is not bound to any company, this is for community, and that's how it will proceed further. Right? And second thing, as Hiran explained, like we are going to give this hundreds of models free for everyone to use and contribute to that as well, and it can be used to any technologies, in any technologies, whether it is mobile app development, Java, .NET or anything. Okay, great. I hope you have all enjoyed this event today. Wait. Yeah, we would like to thank again both the speakers first. I know like we were in touch with Karan as well since last 7 to 8 days. He was constantly upgrading his PPT presentation. He was getting it checked by his team, by our team. Hiral and our team members made that presentation well. Shubham, I know Saturday night he was there at the company till 12 or 1, I guess. Friday night, sorry. And yesterday he was there full day preparing all these things. So again, big round of applause for these two speakers first. Then for volunteers from both the companies who have helped us arrange this in such a beautiful and very well mannered. So a big round of applause for all the volunteers making this YouTube live and all these things. It requires hard effort. So thank you very much. Thank you to every one of you to come in such difficult weather in the morning. Since 9 a.m. or something, the rain was going on, and we also found it difficult to reach over here. But thank you again for coming and be a part of this event. And last but not the least, I would like to thank both the companies, Webocal Technologies and IT Pass Solutions, for again providing us this platform so that we can arrange this event and we can share our knowledge with everyone. Thank you very much. We'll have a photo together just like last time we did. Then we have snacks arrangement. Then you can meet the people you want to know anything from them. Let's have some networking, fruitful networking, and then we will leave. Thank you very much for your day.